Hello everyone, this video is about line factors. Line factors given 2 points on the line, so we have point A, point B. We can find the point, the origin is O, 0, 0. So the factor OA, or the point factor OA, or the position factor OA is from origin to A, from 0, 0 to 1, 2. So it's basically 1, 2. And if you want to find the line factor, you can use the OA. So from the origin you go to A, so from this point you can go in any direction to B or the opposite direction. So here we use OA plus some multiple of AB. So this means you start from A and then you go in the direction of AB, but you can go maybe twice the direction, twice the length of AB, maybe a half of the length of AB, or maybe -2 times the length of AB. So it means you go in this direction. So this is a line factor in equation, right? So we use the letter R. We need some point and some direction. Also possible, you can use also point B, and you can also use the direction from B to A. So for example here, the point C is on the line. So if it's on the line, of course, the -3 -2 here must satisfy the line equation. So it's 1/2 plus -4/3. In this case, the lambda is -4/3. This is called the parameter. So in this case, the lambda value is -4/3 times the direction factor from A to B. Okay, from A to B you go here 3, 3. So from this line factor equation, we can make two equations. In this case, x equals 1 plus 3 lambda and y equals 2 plus 3 lambda. And if you rearrange, lambda equals x minus 1 all over 3, y minus 2 all over 3, and so the x and lambda equals lambda, so you can substitute and you get multiply by 3 both sides. You get y equals x plus 1, which is the usual line Cartesian equation. So if we can find the line equation using the usual coordinate geometry method, why do we have to use factors? Well, because in 3 dimensions we don't have this simple concept of gradient, and we cannot find the equation. The equation is not as simple. For example here, okay, maybe later. So now so this R means any point on the line must satisfy this equation. So it's through some point. So this A is for the point passed. So this is a point factor plus lambda times the direction. And in factor we usually use this in 3 dimensions, and this is the parametric. So we form the equation for each components, x, y, z components, and if you rearrange, lambda equals the parameter is lambda here. So you get this Cartesian coefficient, Cartesian equation. So in 3 dimensions, this is the equation. So it's not as simple as this kind of equation in 2D. In 3D, it's complicated. Right. To check whether a point is on the line or not, let's say we have this line factor equation. Is 579 on the line? Well, you just try. If 579 is on the line, then there must be some value of the parameter alpha that satisfies this equation. So here 5 equals 1 plus 4 lambda, 7 equals 2 plus 5 lambda, and 9 equals 3 plus 6 lambda for the components. And for all the equations here, the lambda value, the alpha value is 1. So yes, the point is on the line. And this point, well, if you do the same thing, the alpha, you get -2, now -1/2. So we have one inconsistency here. So no, the point here is not on the line. Relationship between 2 lines, we can have intersections or skew or parallel. So intersect means we have only one single solution. For example, AB and BC, they meet at B. Skew means they don't intersect, and they have different directions. So for example, AB and GC in this cube, so they never meet because they are on different planes and they are in the same different direction, so they just never meet. And parallel means no intersection and same direction vector. So for example, ABDC, ABDC, they are parallel, and of course they do not intersect, and they have the same direction vector. All right, and now if we're finding intersection of two lines, for example, you have this R line and S line. Intersection means just like the usual y equals y. So in this case, R equals S, we get the first line, second line, because the point of the intersection point here must satisfy both equations. So we have this equation for the x component, 1 plus 4 lambda equals 7 minus beta, and for the y component, z component. From the first two equations, we can solve the simultaneous linear equation into variables. So we have 4 alpha plus beta. If you move the minus beta to the left, you have plus beta, and if you move 1 to the right, you get minus 1. 7 minus 1 is 6, so you get this equation. Same thing here with the second equation. You can multiply throughout by 2, you get this equation. And if you add, cancel out, you have 13 alpha equals this, you get alpha, and you can use one of the equations to find the beta. And then you have to try and plug in alpha and beta to the third equation. Alpha is 1, beta is 2. You check, they fit the equation here. So this means we have an intersection, we have a solution. So the alpha is 1, the beta is 2. You can find the intersection point using the R equation. For the R equation, we have to replace the alpha with 1, or the S equation, replace the beta with 2. Of course, we get exactly the same point. So they intersect at 579. So if you do the same thing, and at this time, so you can solve the first two equations and you get alpha and beta, but when you plug into the third equation, they just doesn't make sense. So they don't make sense here because minus 3 is not equal to minus 13. This means they do not intersect. So this is the case of skew lines. And here, if you do the same thing again, but this time, as you can see, when you subtract, they all cancel out. Alpha minus alpha, 2 beta minus 2 beta. So we have 0 equals something, and of course 0 is not equal to 12 over 5. So this means we have no solution here. So this is the case when we have parallel lines. And actually we don't have to do it this way here. Just look at the direction, 4, 5, 6, minus 8, 10, minus 12. So of course this green values here is twice the red values, right? So if you multiply by 2, multiply by 2, multiply by 2, so we say that the direction of the R line is a multiple of the S green line. So if we have this kind of multiple times the other factor, this means they are actually in exactly the same direction, so they are parallel. And angle between two lines, so if we have a red line, green line, we're gonna find the angle. We use the dot product. So we use the A dot B equals magnitude of A, magnitude of B cos, but we're finding the theta, the angle. So cos equals A dot B over magnitude of A, magnitude of B. So for example, here inverse cos, A dot B divided by magnitude times magnitude. And remember, we use the direction factors only. We don't use the position factor, We don't use the point, we only use the direction, So we get this, and you just use your calculator, and actually we have parallel lines here. And now last one, perpendicular foot. Find the foot of the perpendicular from the point this to the line this. So it helps to draw usually, so just draw a simple sketch. This is the line R, this is the point P. We are finding the foot of the perpendicular. Let's say it's F, and let's say the coordinate